For number 1, it's asking for you to find the average rate of change over the given intervals. So when it's talking x equals -3 to -1, you are trying to find the average rate of change from x equals -3 to x equals -1. So you could do two things. One, you could just count rise over run, and that would give it to you. Or you could use your ordered pairs of -3, 2, and -1, -1, and calculate slope. So whatever works best for you. If it's from a graph, I would say just do rise over run. You're going down 1, 2, 3 over 2. Or you can go through the process of finding slope, y2 minus y1 over x2 minus x1. But when you're given a graph, this is your most time efficient way. Now the next one is from -2 to 0. So -2 to 0, you're going down 1, 2, 3 over 1, 2. So again, slope of -3 over 2. And then from 0 to 1, so you're here at 0, you're here at 1, so you're going up 2 over 1, so the average rate of change is 2. Now for question 2, you're not given a graph, so we're not going to do just rise over run. We'll actually use our slope formula. To find the average rate of change from 0 to 1, you do need to know the outputs. So those are our ordered pairs. So when I plug in 0 to 3 to the x minus 1, my output is 0. And when I plug in 1, my output is 2. So when I go through and do slope for this, 2 minus 0 over 1 minus 0, my average rate of change there is 2. From 2 to 4, for 3 to the x minus 1, if I do 3 squared minus 1, 9 minus 1 is 8. So my ordered pair is 2, 8. And when I plug in 4, 3 to the 4th power is 81 minus 1. So I get 4, 80. So when I do slope here, I get 80 minus 8 over 4 minus 2, 72 over 2, which gives me an average rate of change over the interval from x to 2 to be 36. So you can see that 3 to the x minus 1 in the beginning is definitely growing at a slower rate of change versus later on. And now our next one, f of x, is a linear function 4x plus 3. Could we go through and find our ordered pairs at 0 and at 1 and do slope, and then at 2 and 4 and do slope? Sure. But since this is a linear function, we know linear functions have a common rate of change throughout over the entire function. So no matter what the interval that you're trying to find the average rate of change over, no matter what, it will be 4. We don't even have to spend time finding the points and doing slope because our output would be 4 anyways, because this is a linear function. Rate of change is constant over on a linear function. And then it would ask you to compare. If you look here, if we're comparing over the interval from 0 to 1, notice that the linear function is growing at a greater rate of change over the exponential growth. So this one is our smaller rate of change over the 2, right? This one's smaller because 2 is smaller. But notice as you go farther away from the x-axis, your exponential grows at a greater rate of change. And so here, 4 is less than 36. So this is our smaller of the 2, okay, over the interval from 2 to 4. And then question 3, write the equation of an exponential with a base of 5. So right away, must be an equation. Write the equation. You must have y equals, or f of x equals, base is 5, okay? A vertical stretch by a factor of 2, so that's going to be in front A horizontal translation left 1, so that needs to be part of our function, and since this is 5 to the x, to go left 1, we want it to be plus 1, because it would go the opposite direction of a positive, so that's why we want it to go left. And then a horizontal asymptote of y equals 3. So what that's telling us is that the exponential growth function has shifted up 3 units.